you factor each parenthesis, if they have matching parentheses, then the grouping works. So that's a strategy that you can always check. I want to go through a few more problems and just kind of refresh what some of our techniques were for solving those, just to make sure you don't forget about any of those. All right, so let's say I gave you this one. X squared minus x cubed, or sorry, x to the fourth minus x cubed minus 6x squared equals 0.
Take out an x squared.
Okay. Would you even be able to do the p's and q's with this?
No.
No, because what's wrong?
There's no constant.
There's no constant. And so we know the p-value always comes from the factors of the constant. Since there isn't one, that's a big red flag to us that we need to try something different. So we can factor this. We have a greatest common factor. So if we take out the x squared, then we have x squared minus x minus 6.
Easy method.
Easy method. What would that break into?
X minus 3x plus 2.
And now it's factored, so I want to know what are my zeros.
-2 and 3. 0 plus 2.
So a plain x is always just 0 since it's squared multiplicity of 2. You set x minus 3 equal to 0, you get 3. X plus 2 gives us -2. Again, this was x to the fourth, so we would expect 4 zeros, and we've got 0, 0, 3, and -2. All right, if I ask you to graph, on a test or quiz, I'd probably be more specific and actually ask all the questions. If we want to graph, we know we need end behavior. What would the end behavior be on this? Both ends pointing up. We would need, let's see, we've got our zeros. Does it bounce or go through?
Cross on all, but 0.
Bounce on 0.
So you can't say cross
I'm just not gonna write that out.
I mean, cross through, it's the same. It'll work as long as I know what you mean. Y-intercept. So that's plugging in 0 for all of our x's. You can do it in the factored. You can do it in the original. You'll get the same thing. What do we get?
0.
So if we graph this, we hit the x-axis at our zeros, which are 0, -2, and +3. You guys did a pretty good job on your quiz of drawing the graphs, making them curved, making sure it was a function still, so I was happy with that. Both ends are pointing up, so we have to come down. We're going to hit the -2. We go through. We have to come back and hit 0, and what happens at 0?
Bounces.
Bounces. And we come back and hit at 3, where our graph goes through. And I could ask you to solve some inequalities from this. When you're solving an inequality, really, we're just looking at the graph of it. If I want to know when this function is greater than 0, what am I looking at on my graph?
Negative infinity to -2. Union 3 to infinity.
Right, I want to know when the graph is above the axis. So negative infinity to -2, since there's no equal to, it's a parenthesis. Union parenthesis 3 to infinity. All right. What if I said less than 0? Careful on that one.
-2 to 3.
-2.
Well, if it's not equal to,
Okay.
it would be 2 to 0 parentheses.
Yeah. If I said less than or equal to, you could just go from -2 to +3. Because I just said less than, that means I can't count when it is 0. So I can use this part and I can use this part, but I can't use the place where it hit the x-axis. So we would have to say -2 to 0, union 0 to 3.
I don't know, if we're going with your graph, I think we can do it all.
Let me fix that. Minus a half. Any questions there? What did I do this way? Okay, we could distribute the x. And then merge. Put everything on one side. I'm going to put it in decreasing order. Could you do P's and Q's with this?
Yeah.
Yes. Is there another option?
Grouping.
Grouping. Now, I kind of mentioned yesterday, is it okay to just group like this?
No, you have to add it and make a negative.
Okay, you cannot put a parenthesis after a subtraction. So before I add that parenthesis, I need to make this a negative 27. Then group my parentheses. So the first parenthesis, they have an x squared in common. Second one, what would we take out?
Negative 9.
Let's go ahead and take out a negative because we want the parentheses to be the same. So I want the first term to be positive. Negative 3x minus 2. What do they both have?
3x minus
So if you take that out, you're left with x squared minus 9.
What does that call whenever you break up?
2. Difference of square.
So x squared breaks minus 9 breaks into x plus 3x minus 3.
There'd be a cloud.
They are. Doors must be open. What are the zeros?
Positive 2/3, negative 3, and 3.
Could you say plus or minus 3?
Somebody's running there and tell them shut up.
You could probably just go close the gym door if it's like
Yeah, you do it, right?
Do what?
Oh.
that.
Yeah, we gotta quiet down, huh?
Alright, what would the end behavior be? Down up. We had that 3x cubed. Alright, what did my graph bouncer go through? Yep, they all have a multiplicity of 1. Y-intercept, if you plug in a 0 for x, either the original or our final answer.
18. Oh, you add. Oopsie.
We multiply.
But, yeah, but the 0. No, never mind.
Just be.
Yeah, it would be 18 because it's 3x cubed. You have a 0 in there.
What?
There's a 0 in there. If you put in a 0 in for x, that would make that 0.
Mm-hmm.
18.
That's what she has.
Says 18.
1 and 8.
Okay. Okay.
Alright, so let's graph it. So hit the x-axis at -3, positive 3, and positive 2/3. Y-axis at 18. I'm gonna count by 3s. Alright, so my graph starts down here. We're going through all of my zeros. So I come up, hit my y-intercept, come down, hit the 0, we're going through. So our graph looks something like this.
What would y-intercept just be a constant?
Mm-hmm. Yep, if you plug it in the original.
Two problems to the whole page.
Alright, so far so good?
Round.
Let's try a slightly different one. Make sure we remember all of our techniques.
Easy enough.
Yeah. I don't have a greatest common factor. I don't have enough terms for grouping. But this is kind of like a quadratic. Okay, I have something to the 4th here. We're used to a squared. but then this exponent is half of that, and this is a constant. So we can do our easy method. This works anytime your first coefficient, or your first exponent is double the other one. So if the first one was an x to the 6th, what would your next term have to be? X to the 3rd. If it was x to the 10th, you would have to have x to the 5th. Okay, if it was x to the 1/2.
X is 1/4.
Okay. So if I go through this, x to the 4th, how would I break that down?
X squared minus 10, x squared plus 4.
Multiply -40 and add to -6 is -10, positive 4.
We have to graph this and drop it out.
All right, we'll graph it just for Ryan. So, if I wanted to solve this, let's just set each of those equal to 0. So if x squared minus 10 equals 0. If you add a square root, what else do you need?
Plus minus.
So we have positive and negative square root of 10. If I set x squared plus 4 equal to 0, x squared equals -4.
Plus or minus 2.
Okay, so I got my 4 zeros. Would I have found any of those by p's and q's? No, because none of them were rational. We had no nice zeros there. So if I asked you to graph it, okay, so let's kind of go through. The end behavior doesn't change. It was x to the 4th, so what's the end behavior? Up. All of these are a multiplicity of 1, so what would that do? Through all of them. Y-intercept, if you plug in a 0 for all of your x's, you get -40. So, I graph that. All right, square root of 10 is obviously not a nice pretty number. Let's use our calculator to approximate it. So if you type in the square root of 10, what do we get for our decimal?
3.16.
So it's just a little past 3. And then negative would be a little past -3. Can we graph an I? No, so that's all we have on our graph. So we're going to be going through. I think I wrote it, I just didn't say it. So something like this.
Where would you even graph an I?
You would have to be graphing in the complex, but you don't have it.
Currently?
You won't get to
Oh,
this
good,
class.
good.
All of you have to take more math in college, you can see the complex.
Okay.
How much more?
So what you're saying is don't take college math.
Yeah.
If you are in like,
I
mean, you would-
calculus.
well, there's Calc 1, 2, and 3, and advanced calc, and then like vector analysis,
Are we
vector
taking-
equations.
Calc 1 or taking it like what?
Calc 1 is what I teach.
Okay.
Okay.
Where is this graph less, or sorry, greater than 0?
Negative infinity to square root of negative.
I was just doing square root of 10.
Oh.
Square root of 10 to positive.
All right, where is it less than 0?
3.16.
Let's-
3.16.
Yeah, let's use the square root of 10. It's not rounded. A little more precise. All right, I have one last problem.
I have negative room.
I'm just asking you to solve it. I'm not going to ask you to graph it or anything.
Where'd you synthetic division or something like that? I already called it.
I want to see if you guys
Did you grab it?
can solve this. Start out. You cannot just divide by x squared. It is tempting, but you will lose answers when you do that. If you divide by the x squared, you only get 2 answers, and we need 4. So instead, bring everything to one side. Greatest common factor, we could take out x squared. Then we can do difference of squares. So So my zeros, anytime you have a plain X, your zero is just zero. Because it's squared, that's positive 6, or sorry, X plus 6 would give me a, and X minus 6 gives me positive.
You just can't put it square root. Like, cause I got this one.
Yeah.
I just didn't, I didn't
My
recognize.
way worked a lot. I don't know what you're talking about.
Okay,
Yes, it did.
so here is what we are going to do now. Is everybody listening? So I am done with this section. My plan was to give you guys enough time to maybe get your homework done so you didn't have to worry about it over the weekend. So I am opening up a math Excel assignment right now. It's 10 questions.
That's too many.
Hopefully then we can get that done.
Miss Starkle, from the beginning, if you took a square root from both sides, would it work?
A fourth root? Can you take a fourth root?
Okay, if you did a square root, you would have x squared equals plus and minus 6x.
Yeah, that
So
was.
then you would have to do two equations. X squared equals positive 6x and x squared equals negative 6x.
Yeah.
So if you solve each of these, you get 0 and 6 for this one. This one, you get
Give it.
0 and negative 6, which gives us the same thing.
I thought it still worked.